You are welcome to the Scholar online class. I will be your mathematics teacher for today, and my name is Mr. Abdulwasi. And our topic for today is on trigonometric ratio or trigonometry. So under this, we'll be looking at trigonometric ratio, we'll be looking at inverse of trig ratios, proof of sine squared theta plus cos squared theta is equals to 1. We'll also look at complementary angles, special angles such as 0 degrees, 30 degrees, 60 degrees, 45 and 90 degrees, then the application of the trig ratios. Now, going further, let's now look at complementary angles. In mathematics, there's what we call complementary and there's what we call supplementary angles. When you say complementary angle, it means two angles that add up to 90 degrees. And when you say supplementary, it means what? Two angles that add up to what? 180 degrees. But we are sticking with what? Complementary angles. Now, we are still going to use our right angle triangle. That's, you can see that right angle triangle is very, very important. So still on the right angle triangle on the board, let's say this place is theta. Are you with me? And this one is 90 already. We want to get the third angle here. Now, according to one of the concepts of triangle, we say that the sum of angle in a triangle is what? 180 degrees. It means that angle A plus angle B plus angle C, when I sum it up, it will give me what? 180 degrees. So from what we have here, we have angle A plus angle B plus angle C is equals to 180 degrees. Why? Sum of angles in a triangle. Sum of angles in a triangle. So what's angle A? That's what you are looking for. We don't know. What's angle B? That is 90 degrees. Remember I said that box means 90. And what is C? That's our theta is equals to 180 degrees. What I need here is what? A. So you reserve what you need on the left hand side. You transfer every other thing to the other side. That means I have angle A is equals to 180 degrees minus, when 90 moves here, it becomes minus 90. Likewise, plus theta, when it moves, it becomes minus theta. So therefore, my angle A is equals to 1, that's what? 90 minus theta in degrees. So it means that this angle here is what? 90 minus theta in degrees. I hope you are with me. So this is what we call the complementary angle. So how do we now apply this now? We are still going to apply it on our sine, cosine, and tangent, which are the trig ratios. So applying this for sine theta, the relationship now. The first one is that sine theta is equals to cos 90 degrees minus theta. That's the first complementary angle. The second one, cos theta is equals to what? Sine 90 degrees minus theta. That's the second complementary angle. And these are the basic two that we use. The tan theta is still the same thing, which is related to what? Your 1 over inverse, 1 over tan theta. So now looking at these two, how do we apply these two to solve mathematics? It's very simple. For example, you are given a question and you're asked to find something, let's say in a ratio form. There is a way you can go about it. But before we go further, let's look at how we apply this. Let's look at sine 30 degrees. Now, you all know that sine 30 degrees, when you punch your calculator, it's going to give us what? 0.5000. That is the value of sine 30 degrees, right? Now, let's now take it, applying this trig ratio, or applying complementary angles here. So applying the complementary angle for the first one here, it means that my theta is equals to 30 degrees. Then from our sine theta is equals to cos 90 minus theta in degrees. Anywhere I see theta, I'll put what? 30 there. That means I have sine 30 degrees is equals to cos 90 minus 30 degrees. And therefore, sine 30 degrees is equivalent to what? Cos 60 degrees. So when you punch your calculator, these two, you have the same value. And that's why we call them what? Complementary angles. I hope that is clear. Let's now look at the application of these complementary angles. Let's take one example before we move to the next stage. Now, assuming you have to solve. Example. Solve. Are you with me? Sine x plus 60 is equals to cos 45 degrees. That's the first one. Let's say the second one. I have cos that 3x minus 7 is equals to sine 60 degrees plus x, or let's say sine 60 degrees. If you are to solve these two, there's no any magic to it than to apply your complementary angles. So how do you go about this? Solution. Let's take the first one. I have sine x plus 60 degrees is equals to cos 45 degrees. The first thing here that should be at the back of your mind is how do you make both sides to be of the same ratio? That is, if the left hand side is sine, the right hand side is also what? Sine. Or you change that to what? Cosine, cosine. So that's our first aim. So how do we make it now? We are going to apply the concept of what? Complementary angles. How do we do that? Remember that in our complementary angle, so let's take this one that is just single. From our complementary angle, you know that my cos 45 will be equivalent to what? Cos as what? Sine 90 minus what? Theta. Or sine 90 minus 45 based on our trig ratio, our complementary angle. So I'm going to apply this into this now. That means anywhere I see cos 45, I'll replace it with what? Sine 90 minus 45. So that both sides will what? The same ratio. So therefore, this expression above can be written as sine x plus 60 degrees is equal to what? Sine 90 minus 45 degrees. I hope you are following. So you can see that both sides now what? The same. So the sine, we cancel the sine. And I have my simple expression to what? To carry out. So therefore, I will have what? X plus 60 degrees equals to 90 minus 45. This will give me 5. Then 8 minus 5 gives also 4. Right? So collect like terms. So therefore, I have x equals to what? 45 minus 60. And therefore, x is equal to what? Minus 15 degrees. And that is how you apply your complementary angles. Okay, we are good to go. Let's move on. So the other one, you can try the other one yourself and let me have the answer. So let's move on to the next stage, which is what? Special angles. Now for special angles, here we are talking about angle 0 degrees, 30 degrees, 45 degrees, 90 degrees. And we can, by extension, we can take it to 120, 150, and so on, and so 180, and so on and so forth. But we want to stick to the what? To the major one. Now, special angles. We call them special angles because it means without your calculator, without your 4-figure table, you can know all these angles. That's why we call them special angles. That means you don't need calculator, you don't need table. You can just what? Factor them out by mere practicing. So let's look at this now. So I'm going to start with 30 degrees and 60 degrees. Angle 30 degrees and 60 degrees. So given a right angle triangle, given a triangle, given an equilateral triangle. Equilateral means what? All the sides are equal, all the angles are equal. So given an equilateral triangle ABC, as you can see on the board, this side is equal, this side is equal, this side is equal. With units side as 2 each. So if one side is 2, the other will be 2. And what? Each angle being what? 60 degrees. Each angle being 60 degrees. Are you following? Now the next thing here is to bisect. When you say bisect, this is what you divide into equal portion. So if I bisect this triangle at A, that means by projection you have this. So I've divided it into what? 2 equal parts. This side and this side. So it means these two now will now be divided into what? 1, 1. Are you with me? This 60 will now become what? 30 degrees, 30 degrees on both sides. Are you with me? So I need just to extract one of the triangle, which is right there. So let me call this N, the projection to N. So if I pick one of the right angle triangle, that means I pick this one here. Are you with me? This right angle here. This angle is what? 30 degrees. This is A. This one, this side is unknown. This side is 2. That's AC. And this is N. My NC is 1. So I'm looking for AN. So you can see the importance of Pythagoras theorem. 2 sides are known. We are looking for the third side. To get the third side, you still apply our Pythagoras theorem. So from our concept of Pythagoras theorem, it means I have what? The hypotenuse AC squared is equals to AC squared is equals to what? AN squared plus NC squared. Are you with me? So let's substitute the value. What's our AC? That's 2. Is equal to AN is what? Unknown. Plus NC is what? 1 squared. So 2 squared is 2 times 2, that's 4. Is equals to AN squared plus 1 squared is what? 1. So collect like terms. So therefore I have 4 minus 1 is equals to AN squared. And 3 is equals to AN squared. So take the square root of both sides. So therefore our AN is equals to square root of 3. So I've solved the triangle completely. It means that this third side is what? Square root of 3. So we now want to get our 30 and 60 degrees. So I'm still going to apply our SOHCAHTOA again. So from our concept of SOHCAHTOA, sine, cosine, and tangent, I'm starting with 30 degrees. Angle 30 degrees. So I need to get the 3. Sine 30 degrees, cos 30 degrees, and tan 30 degrees. Sine, from the definition, opposite of hypotenuse. Look at where the angle is stationed. Remember, this is 30, this is 60. So I'm starting with 30 degrees. Are you with me? Now, for 30 degrees, let me remove this 60 for now. This is my opposite, where the angle is facing. Where the angle is resting on is always what? The adjacent. So following these three ratios, it means that what? Sine 30 is what? Opposite. That is NC all over hypotenuse, AC. Invariably, our NC is what? Opposite, that is 1. All over hypotenuse is what? 2. 1 over 2, which is the same as your 0.5. 0.5000. If you use your log table, this is what you are going to have. From our log table, this will give us 0.0, because it's 4-figure table. That's why we must have 4 figures. Now, let's go to cos 30 degrees. Cos 30 is what? Adjacent all over hypotenuse. Adjacent over hypotenuse. So our adjacent is AN, and our hypotenuse is what? AC. Which gives us our AN is what? Root 3 divided by 1. Invariably, that will give us 1.732. If you go to your log 4-figure table, this is what you are going to have also. Then for tan 30, which is what? Opposites all over adjacent. So our opposite is what? NC. And our adjacent is what? AN. So invariably, that will give us what? 1 over square root of 3. And invariably, that will give us 0.5773 or 774. 5774. So if you go to your log 4-figure table, this is what you are going to have also. So these are the three ratios for what? Sine, cosine, and tangent. I hope that is clear. Fine. I will not clear this. Let's now look at 60 degrees so that you see the application of what we mean by what? Our complementary angle. Let's go to 60 degrees now. For 60 degrees. Our 60 degrees. I'm still going to look for the 3 ratios again. Sine 60 degrees, cos 60 degrees, and tan 60 degrees. Now, 60 now, this is where we now have now. So remove all this to start with. We don't need 30, we have 60 now. So put your 60 here. So the position or the orientation of what? The side is what? Has been altered because the angle has what? The position of the angle has changed. So my opposite will now be what? AN. My adjacent is where the angle is resting on. And my hypotenuse still remain what? The longest side, which is our AC. So still using our concept of SOHCAHTOA. It means I have that my sine 60 degrees what? Opposite all over hypotenuse root 3 over 2. Sorry, back to this. Our cos 30 is what? Adjacent over hypotenuse. That's root 3 over 2. Sorry for that. Root 3 over 2, that's 0.8660. 0.8660. Sorry. So back to this. So sine 60 is what? Root 3 opposite over hypotenuse. Root 3 over 2. We still give us 0.8660. Then cos 30. That is what? Adjacent divided by what? Hypotenuse. Our adjacent is 1, our hypotenuse is what? 2, which gives us what? 0.5000. And our tan 60, opposite over adjacent, which gives us what? Square root of 3 over 1, which is same as what? Root 3 or 1.732. which gives us what? 1.732. So, if you compare the two side by side, you see that for sine 30, it's equivalent to what? Cos 60. Sine 30 is 1 over 2. Cos 60 is what? 1 over 2. Which is what? They are complementary. Sine 30 is what? A complementary angle of 60 degrees. Likewise, if you look at cos 30, root 3 over 2, equivalent to what? Sine 60 degrees. Are you with me? Why tan 30 is the inverse of sine 60. So in summary, to summarize this ratio, it means that, to summarize everything, it means that what? My sine 30 degrees is equivalent to what? Cos 60 degrees, which is the same thing as 1 over 2. Then cos 30 degrees is equivalent to what? Sine 60 degrees, which is equal to square root of 3 all over 2, and tan 30 degrees is equivalent to 1 over tan 60 degrees. So, which give us root 3 or 1 over root 3, whichever case it may be. So this summarizes the three trig ratios. 1 over root 3. This summarizes what? Our basic trig ratio of what? 30 degrees and 60 degrees. I hope that is clear. Is that taking? So let's move to the next one, which is 45 degrees. Now for 45 degrees, here we are going to consider our isosceles triangle. And when you say isosceles triangle, it means that two of the sides are equal. Likewise, two of what? The angles are equal. That's what I mean by isosceles triangle. So given a right angle triangle, an isosceles triangle this way, A, B, C, right angle at B, and this side is equal to this side. Are you with me? Now we have to solve this. So it means, remember that we said they are equal, and we know that the angle here is what? Is what? 90. So 90 divided by 2 gives us 45. So each of this side is 45 degrees, and this is also what? 45 degrees. So we can make use of any one of the side. So from what we have here, we are using the word a unit compared to the other one. So if each side is a unit, then we need to get the third side using using Pythagoras theorem again. So from Pythagoras theorem, still the same thing, the square of the hypotenuse, AC squared, is equal to the sum of the squares of the other two sides, AB squared plus BC squared. So my AC is unknown, that's what I'm looking for. Is equals to AB, that's 1 squared plus 1 squared. So therefore, AC is equal to square root of 1 plus 1 will give us 2. So it means the third side is square root of 2. So we have solved that completely. So here we are also going to look at sine 45 degrees. Remember, we are dealing with angle 45 degrees. So we'll be looking at sine 45 degrees, cos 45 degrees, and tan 45 degrees. Now, sine 45 degrees. Remember, I said you can use any of the side. So let's say we are sticking with this side. This is 45 degrees. This will be the opposite. This is my opposite. This is my adjacent. And this is my hypotenuse. Assuming I'm using what? I'm using this angle that is facing this side. So sine 45 degrees, opposite, all over what? Hypotenuse. That is BC. All over what? AC. Our BC is what? 1. Our AC is what? Square root of 2. So when you rationalize this, it's going to give us what? Root 2 over 1. How do you rationalize? Quickly. When you have something like this, 1 over root 2, rationalize means what? You multiply both the numerator and the denominator with the root that you have. So the root I have is root 2. So it means to rationalize what? Times root 2 all over root 2. If I've done this, that means I've rationalized. And 1 times root 2 will give us what? Still root 2. Root 2 times root 2 will give us what? Root 4. Right? So square root of 4 is what? 2. So that gives us root 2 over 2. So when you rationalize this thing as what? Root 2 over 2. I hope it's clear. Then cos 45, the same thing. Adjacent over hypotenuse. That's AB. All over what? AC. Our AB is still 1 all over hypotenuse 1 over root 2. Which is the same thing as what? Root 2 over 2. Why? Tan 45 degrees is opposite over adjacent. That is what? BC all over AB. And that's what 1 over 1, which will give us what? 1. So if you look at this, this is what we have for our sine 45, cos 45, and tan 45. So you can see that what? The summary here, what you can deduce from this. The summary is that what? Sine 45 degrees is equivalent to what? Cos 45 degrees. That is the summary of what we have here. Then the other two special angle, which is what? 0 and 90 degrees. Because of the concepts that we have here, I will just give you this directly because it may be beyond the scope of this class. So for our 90 degrees and 0 degrees, yes, it has its own proven too, but the scope of this class, let's just have the value there. So we are looking at sine 0 degrees, cos 0 degrees, and tan 0 degrees. And likewise, I'm looking at sine 90 degrees, cos 90 degrees, and tan 90 degrees. So sine 0 degrees, the same thing as what? 0. Cos 0 degree is 90 degrees. Why tan 0 degrees? Tan 0 degree is what? Undefined. And why do we say it's undefined? Okay, it's, tan 0 degree is also what? 0, sorry. Tan 0 is also what? 0, 0. That's for the first one. Then for 90 degrees, sine 90 degrees is equals to 1, cos 90 degrees is equals to 0, and tan 90 degrees is what? Undefined. Undefined. So this takes us to what? To the end of trigonometric ratio. With respect to what we have looked on so far, trigonometric ratio of basic angle, you look at Pythagoras theorem, you look at the inverse of trig ratio, we look at the proof of sin square theta and cos square theta is equals to 1. We also look at what? Complementary angles. Then we now take special angle. Under special angles, we look at what? 30 degrees, 60 degrees, 45 degrees, and 90 degrees. And in our subsequent class, we look at the various ways in which you can use this to what? To solve problem. Thank you.